Well, hello! You have probably seen a bunch of redstone clock tutorial videos on the internet where a bunch of pulses come out of your clock and it just keeps repeating and repeating and repeating forever. Well, what happens if you don't want your clock to repeat and repeat and repeat forever? What happens if you only want your clock to go one time? Well, that is what my patented X clock design is going to do, and I'm going to show you how to build it and how it works. I call this thing the X clock because it kind of looks like an X here and an X here, two X's side by side. It's basically a modified hopper clock, but I am going to show you exactly how to build this thing using the materials that are in this chest right here. So let's just take a quick look here. We're going to need some building blocks. I'm using cobblestone in this case, 7 of those. We're going to need 2 hoppers, 1 redstone block, 2 comparators, 5 redstone torches, 2 sticky pistons, plus we're going to need some temporary blocks as well to build this thing. I've just grabbed some dirt here, and we're going to need some items to use in our hopper filter so that we know exactly how long the timer is going to be. All right, let's grab all these items and start building the clock. I like to start this thing by putting down the X shape. And that looks something like this, and then you can break these 2 out. And then skip 2 blocks, and we're going to do the exact same thing again. Something like this. Boom, boom, boom. Now, all these blocks aren't actually necessary. I just think it's really easy to visualize when you have the 2 X's side by side, and this, is, of course, is what gives the clock its name. Next, we're going to go ahead and add a comparator right in there, and turn around and add a comparator right in there. We're going to grab our hoppers and we're going to shift and place 2 hoppers. Oops, not like that, like that. But then we're going to break this one and we're going to shift and place that hopper there. So basically the 2 hoppers are facing into each other. Next, we're going to add some torches. We're going to add a torch up there and a torch down here. Now over here, we're going to add a torch up here and a torch down here. So the bottom one, well, the middle ones, I guess, are on the outside and the inner ones are on the inside, or the top ones are on the inside. We're going to break these 2 blocks because we don't actually need them. We're going to replace them with sticky pistons, one there and one there. We're going to put a redstone block right there, and we're almost done. What we have here is a pretty standard Etho hopper clock. If I were to take some items and put them, let's just put 16 items in there, you'll see that this machine will start to toggle these items back and forth, and the clock should shift. There it goes. And this will just keep repeating forever and ever and ever. But if we want the clock to stop completely, we're going to add 1 more torch right there. And this is basically going to be where the torch that stops the clock and turns it into a one-shot clock. If you want, you can actually get rid of this block right here. It doesn't actually serve any purpose in the clock. I just like to have it in place because I think it makes the clock look more symmetrical. And I think I like things that look more symmetrical. Now, the way to trigger this clock is to turn off temporarily this torch. And we can do that with a number of ways. I'm just going to feed some redstone to here for a second. I'm going to put a button over here so I could do it very easily with a button. And you can see when I push the button, it toggles one time and then goes back. And now it will not go back again because all of the items had filtered back over here and it just stops. Or I could do the same thing with a lever. If I flip the lever on and off, it's exactly the same as using a button. So the thing triggers one time. Off. But here's the neat thing. If I turn this lever on and leave it on, well, it actually becomes an infinite clock, exactly the same way as a regular hopper clock, because basically all we're doing is making sure this torch never comes on and never actually stops the machine. Most likely, though, that is not what we're going to want to do, so I'm just going to break that and stick with the whole button method here, and that way we can fire the clock and decide exactly how long we want the action to go for. Let me give you some insight into exactly how this machine works. As you can see, at its resting state here, so the machine is not on or not moving right now, the redstone block is above this hopper, and this hopper has some quantity of items in it. This hopper has no items in it. When we push this button, this redstone block is going to change places. It's going to move over here, which is going to do 2 things. It's going to lock this hopper and unlock this hopper, which means that items will be able to flow out of here and into here. When this hopper gets full, and therefore this hopper gets empty, this comparator is going to turn off, allowing the redstone block to shoot back over here, and then the process continues. When it gets back to the other end and all the items end up over here again, this torch is actually preventing it from continuously moving. So all we need is a single quick pulse turning this torch off to make the items start to move, and then the rest is automatic, and it just ends when the items have shifted all the way over here and then all the way back again. I should mention that if you try to replace this input line with, let's say, an observer that's looking this way, and then try to trigger it by, I don't know, placing a block or something, even though a signal does come out of this observer, it's not a long enough pulse to turn this torch off for a significant amount of time. So you do have to add one additional thing, and that is just a repeater right here with 2 ticks of delay, and that will make sure that the pulse is long enough to turn this torch off long enough to actually start the clock. So let's try that again. If I break this block, there you can see the timer is now going. So how do we take an output out of this clock? Well, typically what you would do is you would, let's see, just build up some temporary blocks here, something like this. And then I'll climb up here, and I am going to put a piece of redstone right here, here. And then on this last bit, let's just put a redstone lamp. So basically, while the timer is working, we're going to push this button, it's going to switch over, and it's going to power this redstone, light up the lamp, and then when it switches back, it's going to depower the lamp. Now that is slightly less than ideal, and I will tell you why. Because if you have a lot of items, let's say you have a 1-minute timer and you have a minute's worth of items in this hopper, don't worry, I'm going to help you calculate exactly how many items go in the hopper. That's next, but just stick with me for the theory for a second. If it takes a full minute for the items to drain out of this hopper and into this hopper, it's also going to take a full minute for the items to drain from this hopper back into the first hopper. So what that means is that when you fire the machine for the first time, you are going to get a 1-minute timer, but then it's going to take a minute before you can use it again. Well, what happens if you want to use it again immediately? Well, I've got a solution for that too, and it starts by breaking all of this stuff right here. Instead of taking the output from the redstone block, we're going to take the output directly from this hopper, which, as you know, starts completely empty. And then when items move over, it's going to start to fill up, and then it's going to get completely full until the redstone block moves over again, and then it's going to slowly drain out again. So the whole time the timer is active, we actually have items in this hopper, and we can read the amount of items in the hopper, or at least read some items in the hopper using a simple comparator. What we want to do is take whatever this output is, even if it's as low as 1, and boost the signal up to full. So if there are any items in this hopper, we're going to get a 100% output signal right here. That means this lamp will be powered the entire time the timer is going. So let's just push that button. You can see it goes on when the redstone block switches over, but what's cool is it stays on while the redstone block is there until the last item drains out, and now the system is already reset. It can be fired again immediately. There's no need to wait anymore. So if you need a 1-minute timer and then a 3-second delay and then a 1-minute timer again, you can do it because, yeah, the system is automatically, instantly repeating. So far, I've shown you a clock that when you push the button, the lamp goes on and stays on the entire time the clock is active, and then at the very end, it goes off. What if, instead of this, you want the clock to output a single pulse when the timer is over? Well, it's actually pretty easy just to modify what's on the output over here. So I'm going to break this lamp here, and I'm going to replace it with a solid block. I'm just going to use black wool. I'm going to invert that signal by putting down a repeater here, and now I'm going to add another block here. I'm going to put a repeater on here, so this repeater is powered by this torch. Then I'm going to put a sticky piston facing up with a block on top of it. Then I'm going to come down here, put another block down and another repeater, and then that is where the output is going to be. Let's just put the lamp down right there. So just so we're clear here, I've added what's called a monostable circuit here, and as you can see, the circuit is powered by this redstone torch, which has pushed this piston up, and it's now waiting for this torch to go off which will lower this block, and then back on again, which will push the block up, but also simultaneously output a single pulse. And that will only happen when the timer completely runs out. So watch this. So we've pushed the button. We can see that the block goes down. We're waiting for the timer to finish. And when it finishes, boom, there we go. We get a single output. So if we had set this timer to 1 minute, for instance, then from the time we push this button till the time we get this output pulse, the time would be exactly 1 minute. Bonk. Okay, you've seen how to build it, you've seen how it works, but what you haven't seen is how do I know how many items to put in that hopper based on the time that I want to do it? Well, there's a little bit of math involved. Don't worry, I'm going to make this math super duper easy for you. Just follow along. I'll give you the actual answer at the very end, but if you follow along and you can follow it completely, you'll be much better prepared. If you don't know, items transferring from one hopper to another, side to side, will take 2.5 items every second. That's how fast items travel from hopper to hopper. It takes 2.5 items every second moving through hoppers. Or another way to say that is it takes 0.4 seconds for every item. So if we multiply that up a little bit, let's say we put 10 items in a hopper. That means it's going to take 4 seconds for the items to travel from one hopper into the other. 4 full seconds. Okay? Easy, right? Promised this would be easy. We can actually generalize this to say if we take any number of items and we multiply it by 0.4 items per second, that is going to give us the total number of seconds. So for example, just like this back here, if we take 10 items, we multiply it by 0.4, it's going to give us 4 seconds. See, told you this would be easy. Let's go one step further, okay? Because what we're mostly interested in is taking a time and figuring out how many items we need. So let's say we have a time, like a minute or something. We're going to take the number of seconds, we're going to multiply it by 2.5, and that's going to give us the total number of items we need to put in our hopper in order to get that. But let's not forget that the items need to move from one hopper to the other, and then they need to move back again. So it's actually only half of the number of items. So we can show that right here. The total number of items is actually generalized. The total number of items we need for this clock is the number of seconds required multiplied by 1.25. You can get out your calculator to do this. It's really, really easy. And I'm going to show you an example of this. Let's say we need the timer to be exactly 2 minutes long. So the first thing we need to do is establish that 2 minutes is 120 seconds. I think that's pretty easy, right? 60 seconds per minute, that's 120 seconds. So we need a 2-minute timer, that's 120 seconds. We're going to take our 120 seconds, we're going to multiply it by 1.25, and the number we get is 150. So we know for a 2-minute timer, we're going to need 150 items in this clock. And don't forget that items generally stack in Minecraft to 64. So that would be 64 plus 64 and 22 extra items. That's 2 stacks and 22. That's pretty cool, right? So here's a real question. What's the maximum time possible based on the hopper size? Well, we know that our hopper can hold 5 stacks of items, and a stack is 64 items. So if we multiply 64 times 5, we get 320. That is the total number of items that fit in one hopper. And back to one of our earlier calculations, if we take those 320 items and we multiply it by 0.4, we're going to get 128 seconds. That's the time it takes for those 5 stacks of items to move from one hopper into the other hopper. But don't forget, they also have to move back again. So we're going to double that time from 128 seconds to 256. Yes, that's the number. We're going to double 128 to 256 seconds. And if we calculate that back, that actually works out to 4 minutes and 16 seconds because, of course, as we all know, there is 60 seconds in a minute, not 64. So yeah, 4 minutes and 16 seconds is the answer. That is the maximum time possible. One more thing I should mention is sometimes this number can come out weird. Like, you know, if you take 5 seconds, you want 5-second timer and you multiply it by 1.25, you're not going to get a number that's a whole number. Unfortunately, you're going to get like 5 and a bit or something. Just round round it to the nearest number, and that's generally speaking close enough. Unfortunately, this timer can't do exact times when you have odd numbers because it's based on that limitation of hoppers. Hopefully that should be self-explanatory. Now, I know I'm going to get questions about what to do if my timer isn't long enough. If one of these hopper timer clocks will only give me 4 minutes and 16 seconds, what if I need longer? Well, you can always feed the output of one of these clocks, just like this, into the input of another clock. If you do that, make sure you add a second tick of delay here. That way, when this clock fires, let's see, so we've gone one way, and when we go the other way, it's going to fire another signal, which is going to set off the second clock. And then when that one finishes, we could always do whatever we wanted. So that could give us a total of what? Something like 8.5 minutes, or we could just fire that into another clock. I know this is messy, but you could definitely clean this up, make it a little bit tidier. But that's just the working theory. Well, hopefully you found my X clock circuit useful. If you have, please do me a favor. Click that like button. And check out the playlist that's on the screen. That's even more fantastic Redstone tutorials. Thanks so much for watching. My name is Vid, and I will see you in the next episode.